Bergson and the Holographic Theory of Mind. Part 83. We're going to be talking about the Nobel Prize in Physics of 2023 and its implications, namely Schrodinger of 1952 confirmed, and quantum jumps, that concept, dead. So between the 1980s and the early 2000s, three physicists developed techniques for producing laser pulses lasting mere attoseconds. An attosecond is 1 quintillionth of a second, or 10 to the minus 18th seconds. Brief history. In the 1980s, Ahmad Wild, not sure the pronunciation, at Caltech, developed lasers with pulses lasting a few femtoseconds. So these are thousands of attoseconds, or 10 to the minus 15th, or 1 quadrillionth of a second. Pretty small. These blips allowed study of chemical reactions unfolding between atoms and molecules. It's called the world's fastest camera. And Zawell got the Nobel Prize for this, I think in chemistry. In 1987, and Holier, again pronunciation, observed something. Beam a laser on certain gases. Their atoms become excited and emit additional colors of light, oscillating many times faster than the original laser. These were termed overtones. In the 1990s, the Hillier and others were able to calculate the intensities of various overtones, beam an infrared laser at a cloud of atoms, and the atoms emit beams of rapidly oscillating extreme ultraviolet. Then they worked out ways to overlay them, adding up to a new wave, in other words, constructive interference, with peaks surging at the attosecond scale. Now, quoting from the article I'm looking at, coaxing giant collectives of atoms to produce these finely tuned waves in concert is a process Larson liked to an orchestra producing music. Image to remember. The article states, in 1925, Werner Heisenberg, one of the pioneers of quantum mechanics, argued that the time it takes an electron to circle a hydrogen atom is unobservable. In a sense, he was correct. Electrons don't orbit an atomic nucleus the way planets orbit stars. Rather, physicists understand them as waves of probability that give their odds of being observed at a certain place and time. So we can't measure an electron literally flying through space. Emphasize that. Physicists understand them as waves of probability that give their odds of being observed at a certain place and time. But this probability conception underlies the notion of quantum jumps. It is the notion of quantum jumps. It's also the collapse. So a little preview here. This is curiously in the realm of Schrödinger's 1952 article, where I noted in number 60 that some history unstated by Schrödinger, namely wave mechanics, was co-opted by Born in 1926. The same year as wave mechanics was born. Trying to save particles, Born turned waves back into particles. Superposition in waves is natural, but how do you superpose particles? That is, how do they occupy the same space? Answer, you don't. Thus, Born turned this into the probability of locating the particle, or the Born rule, namely taking the square of the wave function psi. Schrödinger's comment in 1927, I am averse to this conception. He did not like the squaring of the wave function and turning that into a probability. So the article goes on. In 1905, Albert Einstein kick-started the field of quantum mechanics with his explanation of the photoelectric effect, in which shining light onto a metal plate launches electrons into the air. He would later win the 1921 Nobel Prize in Physics for this theory. Before the age of attosecond physics, physics generally assumed that the chain of reactions that led to the liberation of these launched electrons was instantaneous. Underline that again. They assumed that the chain of reactions that led to the liberation of these launched electrons was instantaneous. Again, that is the quantum jumps. And the same thing, the probability collapse. But in 2010, Krauss and his colleagues showed otherwise. They used attosecond pulses to clock electrons that were knocked loose from neon atoms. In particular, they found that an electron in a lower energy state flees its host 21 attoseconds faster than one in a higher energy state. And in 2020, another group showed that electrons escape tens of attoseconds faster from liquid water than from water vapor. Uh-oh, not the jumps. Not the jumps. Things are being observed happening in what was used to be thought of as instantaneous quantum jumps. No time. Suddenly there's time. So we are back to Schrodinger, 1952. After 70 years of ignoring his warning that the wave equation means waves and quantum jumps are a fiction, or more precisely ignoring his devastating arguments that there are no such things as jumps, that experiments are easily at hand to show that things are continuous. For example, with respect to the instantaneous, supposedly, energy transfer between two wave packets. He says it obstinately refuses to take stock of the principle of superposition, which enables us to envisage simultaneous gradual changes in any and all amplitudes without surrendering the essential discontinuity, if any, namely that of the frequencies. Now you can call frequencies discontinuous, 100 versus 200 versus 300, but that's a number. It's a fiction, an abstraction itself. That's why it says if any, if there's any actual discontinuity. With respect to the photon-based photoelectric effect, little energy packets called photons. But according to wave mechanics, as put forward by de Broglie and myself, the interpretation does produce without delay electronic wave trains of the higher frequency or higher velocity that we observe emerging from the metal. After this has been recognized, is the probability scheme any longer needed? In other words, the collapse, the square of the wave function. Has the idea of mysterious sudden leaps of single electrons not become gratuitous? And he adds, the waves are there anyhow, and we are not at a loss to prove it. We need only to put a tube of crystal powder in the way of the emerging beam and produce an interference pattern of the type first achieved by G.P. Thomson. So, will they acknowledge their mistake? He opened with a warning to physics in this article. Are there quantum jumps? 1952. Quote, a theoretical science unaware that those of its constructs are considered relevant and momentous are destined eventually to be framed in concepts and words that have a grip on the educated community and become part and parcel of the general world picture. Where this is forgotten, will necessarily be cut off from the rest of cultural mankind. And another, in the inseparable union of speech and thought, the primacy, rather paradoxically, rests with speech. When we hear the same words again and again pronounced with authority, we are apt to forget that they were originally meant as an abbreviation. We are induced to believe they describe a reality. And what have we so commonly seen, so commonly stated? Time is discontinuous. The universe transforms in discrete jumps. Our perception, that is our experience of continuity, like the coffee stirring, is only an illusion created by consciousness. This is an underlying buttress for AI in its discrete states. Even theorists like Bohm. What we're proposing here is that in the quantum domain, this model is a great deal better than the classical notion of interacting set of particles. In principle, discontinuities may be allowed in the manifest tracks, and these may provide an explanation of how An electron can go from one state to another without passing through states in between. So even Bohm, for all his perceptive ability, bought this notion from Born. Now recall this. Coaxing giant collectors of atoms to reduce these finely tuned waves in concert is a process Larson liked to an orchestra producing music. Finely tuned waves in concert. This is the same as the organic growth of the rose, or the orchestra playing a symphony in harmony. These are simultaneities, simultaneous causal flows, the massive resonating atoms. All is simultaneity, else you're not going to get the higher frequencies, the overtones. These cannot be relativized. You can't have a physicist in relative motion passing by, declaring that these other guys are, the orchestra is in motion, or the rose is in motion, or somebody observing the rose or the orchestra, and that therefore these things are non-simultaneous. For example, that the rose in its organic growth hits the X points simultaneously. This cannot be relativized, or in this case, the organic growth is destroyed. The growth pattern is distorted. Or the bass fiddle on one side, the drums on the other, in perfect sync. This can't be relativized. The synchrony, the harmony of the orchestra is gone. And you're calling the perception of the static viewers to be illusory. Or the precise synchrony of the waves in that group up there, affecting increasing frequencies, the overtones. This cannot be relativized. Physics is staring right at the refutation of special relativity and the relativity, so-called, of simultaneity as well. These are causal flows that cannot be relativized. How long before they see this? One more quick one. Remember the pole-barn paradox. In this paradox, we have a longer, say, telephone pole. In its resting state, it's too long to fit into a certain barn. However, when the pole is launched into motion at the velocity of the speed of light and flies through the barn, there is a period where the pole, due to its length contraction, actually fits into the barn. Here, physics without hesitation invokes the reciprocity of observers. That is, you can have an observer sitting on the barn and an observer on the pole. And they say, well, I can put the barn and the observer on the barn in motion, and the pole is now static and at rest, and now the pole does not fit. Hence, they say this is not a real, not an ontological, not a physical shrinking. So, obviously then, it's what is termed the measurement effect. It's the effect of Einstein's light rays in clocks, which are the rulers here. And you've got a measurement effect, the effect of the rulers. But as the time slowings must also be for the equations, the length equation and the time equation of Lorentz are compensatory. Time units expand as length units shrink. So why is physics so sure that the pole will not shrink? After all, physics considers the clock slowings very real, very ontological, very physical, and indeed they are. And again, remember, the equations are compensatory. So the pole has to be shrinking as well. So do the experiment. Use a mini pole or rod and rig a mini barn with laser doors. See if the mini pole at high velocity fits momentarily in the barn. Yes, accelerating something other than a probe photons near the speed of light is a challenge, but I have faith in physics. If they can get to the attosecond, and this is the point here. Now you have lasers, my laser doors, at the attosecond time frame. So I would suspect this can be done. Of course, then the explanation of Michelson-Morley is gone. And we're back to the ether, where these waves actually likely exist. So when it comes to the subject of the generation of these ultra-high frequency overtones, a correspondent friend of mine sent some links warning physics is very much relying on the discrete time framework and this generation framework, the discrete frequencies. the wave equation with its limit approximation. We're taking a limit, it's always an approximation. Yet it is clear that the implication, the vision has been opened. There is no limit to the tininess of the unit of time. Attoseconds are but a temporary stop at tininess, just as femtoseconds was a temporary stop. There's no end until you hit the indivisibility of matter and time. That is, the indivisibility of the flow and the indivisibility of the matter field, for that matter. The jump facade has been now ripped away. There's continuous transformation between states, just as Schrodinger was arguing for. So perhaps, all this will begin to work on them. Next we'll see. Till then, signing off.